In this video, we'll show you what happens to a coffee bean during a roast. In order to show you, we'll use a virtual coffee roaster. The left side of our roaster shows a portion of the drum. This is where we'll illustrate what happens to the beans. The upper right shows the software, where a roast curve will appear. The bottom right will show the names of the stages and events, accompanied by a short explanation. We'll start by preheating the roaster. The roaster will be up to temperature fairly quickly. It is important the roaster becomes saturated with heat. For larger roasters, this takes at least 30 minutes. After preheating, all heat transfer methods will be available. Heat by contact due to the hot surface of the drum, heat by convection due to the hot air in the drum, and heat by radiation due to the infrared radiation that's emitted from the drum and other parts of the roaster. Despite heating properly, the first roast is often of a lesser quality. The hopper is opened and the beans fall into the drum. This is called charging the roaster, or shorter, the charge. Before charging, the beans should not be left in the hopper for too long, otherwise the beans will dry out in the hot environment of the roaster. As soon as the beans enter the hot drum, they'll start to absorb heat. Moisture slowly evaporating from the bean provides some protection against burning in this extremely hot environment. Charging the green coffee has lowered the temperature in the drum. At the turning point, the temperature drop stops and the temperature starts to rise again. Let's zoom in for a minute on measuring temperatures. The sensor associated with a blue line is called the bean probe. One might assume, and we often say, this probe measures the temperature of the bean. Take a good look at the start of the blue line. Directly after charging, it reads 119 degrees Celsius. We have just filled the drum with beans at room temperature, say 20 degrees. It is impossible those beans have reached a temperature of 190 degrees immediately after charging. Some roasters are equipped with an infrared sensor. These sensors are more precise in measuring the actual bean temperature. As shown and expected, the temperature of the bean does indeed start at room temperature. So, the bean temperature measures the temperature in the sensor and not the actual temperature of the bean. From the perspective of the coffee bean, there is no such thing. The beans keep increasing in temperature during the entire roast. Despite the fact that a turning point is based on the temperature in the probe and not the bean, most roasters do watch this point. When one works for a long time with coffees on a certain roaster, it is the first indicator that will tell us if a roast is behaving as expected or if altered conditions might affect the roast. The beans have now lost so much moisture the color is starting to change. The moment the greenish color of the bean has disappeared is called the yellowing point. The Maillard reaction started around 120 degrees and is intensifying. It causes more rapid coloring of the beans. The beans have the color of cinnamon at this point. From the charging of the beans up to this point, the beans have been absorbing heat from the roaster. We call this the endothermic stage. At this point, the process changes and the beans slowly start to produce heat. This is the start of the so-called exothermic stage. Most of the moisture has now disappeared. Most of the remaining water vapor is trapped in the cells of the bean. This vapor takes up more and more space. By this time, the chemical structure of the bean has changed. The cells are no longer pliable. Due to the still expanding vapor, the cells finally burst open, causing the bean to expand. One usually registers the first crack as the moment where multiple beans crack at almost the same time. When we continue to roast for a longer time, the beans suddenly expand again. This time because the cells of the bean can no longer cope with the pressure built up by the CO2. This is called the second crack. Nowadays, fewer coffees are roasted into the second crack. Around the second crack, the bitters are increasing rapidly. This is clearly noticeable with non-espresso brewing methods. The specific taste characteristics of the coffee are lost. Our roast ends by dumping the coffee into the cooling tray. The beans must be cooled below 30 degrees within 5 minutes using air or water. The sooner, the better. If the cooling takes too long, the exothermic reactions continue, and therefore the roasting. This is called baking. The taste becomes flat because the acidity decreases. Bread and bread crust-like aromas arise. When the coffee is cooled with air, the air is drawn through the bottom of the cooling tray. When the ambient temperature is high, additional fans might be needed to make sure the coffee reaches a temperature below 30 degrees within 5 minutes. Quenching is a process where water is vaporized over the beans for about 30 to 90 seconds. The vapor rapidly extracts heat from the coffee. If the system is properly set up, the water will evaporate entirely and the coffee will not be affected. This technique is usually applied to roasters with a capacity over 25 kg. The cooling time will be reduced to 3 to 4 minutes. Let's recap by plotting the different stages and events into a single graph. We'll start at preheating. For larger, cold roasters, this will take at least 30 minutes. The roaster should be saturated with heat. The roast starts when the beans are charged in the drum. From the charge up to almost the first crack, the beans absorb heat. This is called the endotherm stage. From the charge up to the turning point, little seems to happen. The beans are mainly absorbing the heat. The turning point is the moment where the temperature in the bean probe is rising again after its initial descent. After the turning point, the moisture in the beans is getting hot enough to vaporize more rapidly. The beans are starting to dry and the roaster is filled with water vapor. After a short time, the color of the beans start to change. This will continue until the very end of the roast. We have reached the yellowing point when the greenish color of the beans has disappeared. After a short time, the color of the beans will look like cinnamon. Right before the first crack, the endotherm stage ends and the beans slowly start to emit heat themselves. This marks the beginning of the exotherm stage. By this time, a lot of moisture has disappeared from the bean. So far, the cell structure of the bean has been pliable. Due to the chemical reactions, this is now changing. The remaining moisture in the bean is captured within its cells. Due to the increasing temperature, this vaporized moisture is taking up more and more space. Since the bean is no longer pliable, the walls of the cell can no longer accommodate the expanding vapor and break. When several beans crack at almost the same time, we have reached first crack. When we continue long enough after the first crack, we will eventually reach the second crack. The second expansion of the bean is caused by the increase of CO2 produced in the bean. The cooling stage starts as soon as the beans are dumped into the cooling tray. To prevent baking, the bean should be cooled down to below 30 degrees Celsius within 5 minutes. Thank you for watching this video. I hope you enjoyed.